Hey guys, welcome to day 35 of 100 Days of Code. It's Angela here again, and today we're going to be learning all about API keys, authentication, environment variables, and also how to send SMS using Python. It's going to be a pretty packed day, and we're going to be learning a whole bunch of things. And the goal is to look at even more advanced ways of using APIs and looking at how we can authenticate ourselves with an API provider so that we can get access to more precious data. Now, we're also going to be looking at how we can use an API like Twilio to send SMS messages to ourselves so that we can get an alert wherever we are. And finally, we're going to be taking a look at what environment variables are in association with how they're used for safely storing API keys. What all of this knowledge is going to amount to is to build a rain alert application. So we're going to be writing Python code that is going to send us a text message in the morning just before we head out, telling us to bring an umbrella if it's going to rain in the day. So this way, we don't have to check the weather. We know that our trusty application is always going to alert us via an SMS message if we need to bring an umbrella before we leave home. So that's the goal. And if you head over to the next lesson, we'll get started building our application and learning about API authentication. The first thing we're going to explore is how to authenticate ourselves with an API provider so that we can access more secure and more valuable data from the API providers. Up to this point, we've learned about API endpoints, so figuring out what is the URL that we need to hit up in order to get a particular piece of data. We also looked at API parameters, so passing in different inputs so that we can get different pieces of data back from the API provider. Now we're going to take one step further and look at how we can use APIs that require authentication. Previously, all of the APIs that we've used were free APIs. They were provided completely free, and we can access all parts of it without any sort of payment tier. Now, this is because the data that's contained in those APIs are very simple, and nobody is going to be using that data to build a very fancy or big commercial application. Now, on the other hand, there's other types of data that are very valuable. For example, weather data, because it takes a lot of energy and time for somebody or some company to collect all of this data and provide it for you. In these cases, some of these APIs can have a paid tier. So you actually have to pay if you're running an application or if you have a company that needs to get this data very frequently and you need to get large amounts of the data. Why do people charge for APIs anyways? Well, if you think about something simple like the weather, it's not actually that simple. How do you even get the weather if I asked you to figure out the weather without using some sort of website or tool? Well, in this particular case, Open Weather Map, they have access to over 4,000 weather stations across the globe. And then their data scientists will take that weather data and look at the satellite images and process that data in order to figure out the weather and predict the weather for each city in the world. As you can imagine, that's going to be really resource intensive, and it's going to require a lot of employees and also server maintenance and electricity costs, right? So for all of that hassle, if they're going to provide this data for you, then it's reasonable that you should be paying for it, right? Essentially, you can see a lot of APIs as a way of selling data. If you own some sort of privileged piece of data that you are constantly updating or you are actively generating, for example, weather data from satellite images or financial data, then it's reasonable that you should be charging for this data, especially if somebody's going to rely on it heavily in order to build a commercial app or a company. But luckily, most of these APIs provide a free tier that allows you to test out the application. And if you're somebody who's just learning the ropes, then it doesn't make sense to charge you. It only makes sense when your application or your service has a lot of users, and then you start going into the paid tiers. Now, how do you prevent people from abusing this free tier? Because anybody can say, well, I'm just learning, you know. You could be somebody who's running a 1,000 employee company and you could claim that you're just learning. So the way that they prevent people from abusing their service is through something known as an API key. And this is almost like your personal account number and password. This is the way how the API provider can track how much you're using their API and to authorize your access and deny you access once you've gone over the limit. Now, different API providers tend to have different ways that you can authenticate yourself with them, but most of them involve some sort of an API key. In the next lesson, I want to show you how we can implement the Open Weather Map API, authenticate ourselves with an API key that we generate, and get the live weather data. So for all of that and more, I'll see you on the next lesson. Now, whenever we start using a new API, the most important thing is to read the documentation. I know it's really tempting to skip over the instructions and just get right into it. I'm also the sort of person who buys a lawnmower and throws away the instruction manual, and then 2 days later something breaks and I just want to hurt myself because it would be so much easier if I had actually read the instruction manual. But in this case, it is really important. So let's head over to openweathermap.org together and let's go to the API section to see their API documentation. As you can see, this API provider actually has several products. So you could look at the current weather data, the hourly forecast, the one call API, the daily forecast, and a whole bunch of other things. So each of these have their own endpoints. And if we take a look at the API doc, you can see this first one. The API is api.openweathermap.org/data/2.5/weather. That's the endpoint. Whereas the hourly forecast is pro.openweathermap.org/data/2.5/forecast/hourly. So depending on what it is that we need, we can tap into each of these different APIs. Let's start off with an easy one. Let's try and get the current weather data for the city that we're in. You can see that this part is the endpoint, so the URL that we're going to tap into. And then we have some parameters. The parameter where we can specify the city name is Q. So that's the name of the parameter, and then we have to provide a value. Now, in addition, there's another parameter which we have to include with all of the API calls to this particular service, and that is an app ID. We have to get hold of an API key in order to use this service. And they show you an example here. If we click on this URL, it takes us to samples.openweathermap.org. And this is just some sample data where they provided a sample app ID. Now, we can get our own app ID for free by simply signing up to this weather service. And once you register and sign in, this is the page that you see. So we can now go into this section called API keys and grab our API key here. So you can create as many keys as you want, and you can provide a name that's associated with the final usage for that key. So I've named it Python, and now I'm going to copy this API key and I'm going to place it into my project. So I've started a new project called Rain Alert, and inside the main.py, I'm going to create a API key, and I'm going to save that key that I copied into a set of double quotes as a string. Now, once I've got my API key, I can actually test out this API call. So I can replace this part with my city name, which is London, and then I can add my country afterwards just to make sure that it goes to London, UK, and not London, Ontario, or somewhere else. And then finally, I'm going to paste in the API key that I copied over just now. And now when I hit enter, and as long as my API key is valid, I should get a result in the format of my weather data. Now, I want you to make sure that your API key works as well by using the same method. But remember that you have to get hold of your own API key by signing up to Open Weather Map if you want this to work. Make sure that you replace this part with your own API key. Otherwise, it's not going to work. Now that we've seen that this particular API call actually works, let's see what happens if we provide the wrong API key. So if I just make up an API key and hit enter, you can see we get a code back, which is an HTTP code called 401. And we can also get a message telling us that that's an invalid API key, and we can go to this URL for more info. Now, remember, in previous lessons, I mentioned that HTTP status codes are the codes that we get back when we try to talk to another server. So in this case, we got the 401 code back, which means unauthorized. And when you get this code back and you're working with an API, it usually means that your API key or your way of authorizing with the API key is somehow not working. So that is the thing that you should examine. We can see that for this particular API provider, we have to authenticate ourselves with their server by providing the API key as a parameter. So now I want to give you a challenge. I want you to go to the API doc for their one call API. This one call API gives you a bunch of things. It gives you the current weather, the minute forecast for the next hour, the hourly forecast for the next 48 hours, and the daily forecast for 7 days. My challenge to you is to make an API request from PyCharm to the one call API and to locate the hourly forecasts for the next 48 hours in the JSON response that you get back. Now, I could tell you exactly what to do, but it's really good to get some practice reading API documentation because after all, in the future, you're going to be using loads of different APIs and they all have different ways of working with their services. Have a look at this page. I'll link to it in the course resources, and I want you to implement this API call by providing a latitude and longitude of where you currently are. Now you can leave this exclude parameter out and make sure that you add your personal app ID by getting hold of your API key. Now remember, you can get your current latitude and longitude just by going to latlong.net and then typing a place name and then clicking find. Don't worry if it tells you a bot is detected. Just go back to the website after a little while and try again. At some point it should show you your latitude and longitude, which you can then plug in as a parameter to this particular API call. So if you managed to work through all the lessons yesterday, then this should be a piece of cake for you. Pause the video and give that a go. All right, so if that was hard at all, make sure that you've not skipped yesterday's lessons because I go through in detail how to hit up a API endpoint, how to provide parameters, and how to essentially complete this challenge. But hopefully you managed all right and you're just here to check the solution. As always, we're going to start off by importing our requests package. Remember that if you're creating this file from scratch and you haven't downloaded it from a zip file, then you'll have to install this module manually. So if you click on it in PyCharm, you get a little red light bulb, and then when you click on the down arrow, you can install that package. Simple. Now, once you've got requests installed, we can use the get method to pass in our endpoint. Now, the Open Weather Map endpoint is the one that we see in the API docs. So it's everything up to, but not including the question mark. So all of this. And we can paste that in and save it as a string. That is what we want to make our get request to. So OWM endpoint. And in addition, we're going to provide some params. So this is going to determine what kind of data we get back. And in this case, it's going to be the weather for a particular location that we're interested in. Let's create our weather params. And this is going to be a dictionary. And we have to follow the keys that are provided in the API docs. So the parameters that we can provide for this API are lat, which is the latitude, lon, which is longitude, and a lot of people make typos here because they add a G. It's actually just LON. That's the name of the parameter key. And then there's exclude, which tells you which parts of the weather data you want to exclude. And finally, the app ID, which is your API key that you got earlier on. In our case, we want to provide a lat, the latitude, we want to provide a lon, LON, which is the longitude, and we also want to provide our app ID. Now, our app ID is simple. It's simply the API key that we got earlier on. And again, just as a reminder, this key is not going to work. You'll have to register and get your own for it to work. Now, the latitude we're going to figure out by using latlong.net. So I'm trying to get the weather for where I currently reside, which is London. So my latitude is this value and my longitude is this value. Make sure that you copy everything, including any negative signs like this. So these are going to go in as floating point numbers. And now that we've completed our weather params, we're going to pass it in to this method. And now we can save the output that comes from this as the response, and we can print the response dot status code to see if it was successful. So now let's go ahead and run our main.py, and you can see the response code we get back is 200, which means everything is A-OK. Now, if you get a response code that's 401, that means your API key is probably not valid, or you've misspelt the name of that key. It should be app ID, all in lowercase, as they've shown us in their documentation. If you did get 200 though, that means everything was successful and we can now tap into the actual data. So let's tap into the response.json and let's print that out. So there you have it. We've got all of the data here that came back from that API call. And if you scroll, there's actually quite a lot of data that's in there. Now, in order to view this, it's not very easy to look at it in the console. So I'm going to triple click on this and copy all of that string. And I'm going to view it in an online JSON viewer. So I'll link to this as well, but you want to paste that JSON you got back into this and you can see, wow, what a mess, so much data. But if you click on viewer, then you can see it's nicely formatted all of that data for us to get the current data, or you can get the hourly data or the daily data. So this is the data that's effective for this latitude and longitude, and this is the current time zone we're in. So in my case, I want to know the hourly data for the next 12 hours. So I can expand this list and you can see there are 48 data points here. If we take a look at each of those, they give us a timestamp for when this predicted weather is valid, the temperature in kelvins, the pressure, humidity, but also the actual weather data. The weather data is a list which contains a bunch of dictionaries. In this case, there's only one, and it's telling us that right now, where I am in London, there's scattered clouds, which is pretty normal if you've ever been to London. At least it's not raining. We've now managed to use this Open Weather App API, authenticate ourselves with an API key, and get the required data back from this service. So in the next lesson, we're going to dig into the data that we got back and we're going to use it to figure out whether it's going to rain today. So for all of that and more, I'll see you on the next lesson. In order to create my rain alert Python script, I want the script to be run every morning at 7 a.m. Let's say that I'm going to head out of the door at 8 a.m. in order to go to work. I want my script to run at 7 a.m., check the weather for the next 12 hours, so the time when I'm going to be away from home, and then send me a text message if it's going to rain today so that I can remember to bring an umbrella. That way I'll get notified before I leave home and I'll know how to prepare for the day. The data that we got back from OpenWeatherMap contains the hourly weather forecast for the next 48 hours. So it starts from 0 and goes up to 47. Now we're only interested in the next 12 hours because if you imagine the script is run at 7 a.m., then plus 12 hours, that's going to be 7 p.m., by which time hopefully I'm already on the way home and I don't need to worry about whether if it rains or not. That's the goal, and if we head back into our code, what we want to do is firstly modify certain parts. Now we know that at the moment the response code that we're getting back from calling this API is 200, so it's successful. So we're going to call raise for status so that if there is a problem and we don't get a 200 code, then we actually raise an exception. Now next, we want to save our response.json as the weather data. And then we're going to work with this data in order to get the particular pieces that we're interested in. So if we look at this JSON that we get back, firstly, we don't really care about the current weather or the daily weather. So when we look at the API documentation, which is probably the hardest part, making sure that you're diligent enough to read the entire documentation, there's often some good nuggets in there. For example, in this case, we can add another parameter called exclude, which allows us to exclude some parts of the weather data that comes from the API. This should speed up the API fetching process. It also means that we're transferring less data across the internet. So we can get rid of the current, minutely, and daily. We're only interested in the hourly. And we have to provide this as a comma delimited list. So if we take a look at their example, you can see here they've said exclude, and then they've said hourly, comma, daily. And notice how it says without spaces. So as I always say, this is like going into somebody else's house. Everything is different. The way that the washing machine works is different. The way that their dryer works is different. So you really have to look at the API documentation when you're working with a new API, just so that you're not caught out and you understand exactly what you have to do in order to be a good API user. Let's go back into our code and let's provide that extra parameter. So that was called exclude. And the thing that we want to exclude is going to be provided as a string. So we want to get rid of current, minutely, and daily. So we're going to add that into the string and make sure that we separate each with a comma and without spaces. Now, when we hit run and when we get back our weather data and we print it out, and we copy this and put it into our online JSON viewer. So let's replace all of the stuff that was there before. And you can see the JSON we're getting back is now a lot simpler. We're only getting back the hourly weather forecast. So that's step one done. The next step is to dig through this hourly forecast and get hold of the thing that we're interested in, which is the actual weather condition. The way that weather services tend to provide the weather condition is through an ID. And I know this because I read the API documentation. It's not because I'm some sort of weather geek. Although, I mean, that's not a bad thing to be, I guess. If we take a look inside the API key, if we scroll down in this documentation past the examples, you can see it provides all of the fields in the API response. So these are all of the things that we could possibly get back and what they mean. And you can see there's some really interesting things like the UV index, or you can get what does the temperature feel like based on the wind chill and actual ground temperature. But what we're mostly interested in is the hourly data, and then inside that, the hourly weather data. So this hourly weather ID is a weather condition ID. And when you click on that link, it takes you to this table that shows you all of the weather condition codes that we could possibly get back in this particular field. Now, you can see that all the codes that start off with a 2 means some sort of thunderstorm. And then starting with 3, that means some sort of drizzling. Starting with 5 means rain. Starting with 6 means snow. And then afterwards, we have the 700s. So these are atmospheric things like a bit of mist, a bit of smoke, a bit of dust or fog. And this is also, incidentally, the reason why this weather key actually has a value that's in the form of a list. You can see that's denoted by the square brackets here. So there could actually be multiple weather conditions for a particular place at a particular hour. And that's because you could maybe have snow, but you could also have fog at the same time. Now, when I looked through a lot of the examples and the documentation, it seems like the first item in that list is the main condition. So if it's going to rain, then it's going to be in that first item in the list of weather conditions. Inside that list, we have a dictionary or many dictionaries. Each of those contain a weather condition ID, the main condition name, and the description. So if we look at this ID code 802, we can decode it in this table, and you can see it means scattered clouds. 20 to 50% of the sky is covered in clouds, basically. Based on this list, we can say that, well, anything that has a code less than 700, then we probably will need an umbrella. I'm not sure how you stand on the umbrella in snow situation, but I personally do like to hold an umbrella when it's snowing, especially because I live in a country where the snow is not crazy. It's just sort of, it's never sort of the beautiful snow where it's thick and it gets caught on your eyelashes. It's the sort of annoying slush that's just sort of snow, but it's sort of like somebody spitting at you. So in my case, I would prefer to have an umbrella if it was going to snow. I'm going to check for the codes that we get back from the Open Weather Map API. And if the code is less than 700, then I'm going to advise my user to bring an umbrella. Here's a challenge for you. Can you figure out how to look through the data that we get back, which, remember, looks something like this, get hold of the first 12 items from that hourly list, and then look at the weather and the first item in the weather list and also the ID. So you're going to go all the way down to this, but remember you're going to do that for all of the items and you're going to check for the condition code. Now, if any of those ID codes are less than 700, then you want to be able to print out, bring an umbrella. So that's the goal. And the actual implementation, I'll leave up to you because there's quite a few ways that you can do this, but I'm sure by now you're well prepared with all of your tools in Python to figure this out. If you want to make sure that your code is actually working, you can switch to a latitude and longitude that is definitely raining. So if you go to venturesky.com, they actually show you the live weather forecast. So we can look at precipitation, which is basically rain, and we can find some sort of unfortunate place which seems to be really heavily raining. For example, this place in Poland, Łódź, and if I spell that name correctly, Łódź, and then I'll add the country code, Poland. And just to make sure in the map it's actually found the correct place, yeah, that looks pretty much it, then I can switch out my latitude and longitude with this rainy place. And that way I know that at least one of the results I get back is definitely going to contain some sort of rain. Now, if we look at their hourly data, you can see that the weather is basically just rain, rain, rain. So between looking at places which are sunny and places which are rainy, you should be able to get your code to work so that it tells you in the next 12 hours if any of those condition codes are less than 700, which means it's got some form of precipitation. Pause the video and give this a go. All right, so let's narrow down into this weather. If we want to get the weather for the next hour, then we have to tap into the first item in our hourly list, and then we get hold of the weather, and then we get hold of the first item in that list. Under the ID key, we'll get the actual value. We've talked about this in detail in previous lessons. If you've skipped a lot of lessons and you've come here directly, then it's going to be a little bit confusing, and I recommend to review the previous lessons before you continue. Instead of printing the weather data, let's drill down. Let's get to the first item here, which is hourly. If we provide a set of square brackets, and then we can access the value inside the hourly key, like this. And now we've got a list with all of the hourly data, and it looks pretty much like this. Now you can confirm this by also pasting this into the JSON viewer, replacing the previous text that was there. You can see we now have our 48 items in this list of hourly data. To drill further down, let's get hold of the first item in that list by providing a square bracket and then the index, which is 0. Now we're into the first item, and this is what the data looks like. It's a lot shorter. Now we want to tap into the weather condition. So that means yet another set of square brackets and then the name of the key, which is weather. Now it's pretty simple. It's simply giving us a list with only one item. Let's tap into that one item by using, again, square brackets 0. And now we've got just a simple dictionary, essentially. So if we want to get hold of the ID, then it's the final square bracket and the key, which is ID. The current weather data ID code is 500, and that, of course, refers to light rain. The next problem is, how do we get hold of the first 12 items that we get back in our weather data? In previous lessons, we covered the Python slice function, which could work for this by simply providing a value and slicing a sequence like a list or a tuple to get hold of a particular section of that list or tuple. Now, you can also use the Python slice operator, which is the square bracket and a colon. And this is probably a more Pythonic way of doing things. And you'll see more people doing this in the wild than using the slice function. So let's do it with this notation. We're going to use this version. So we're going to tap into a list and then provide a colon and then where we want to stop, because we want to go from the beginning of the list through to stop -1. We know that it's this part of our code that gets us to our list of hourly weather forecasts. So we want to create a slice from that data. So let's copy that and comment this line out. And then I'm going to create my weather slice, which is going to be generated from the weather data under the key called hourly. If I print this, you can see it starts off just simply being a list with all of the weather forecasts. Now, if I go ahead and slice this, I'll use that syntax that you saw earlier on, where we have a square bracket, a colon, and then where we want our slice to end. And we want this slice to go from 0 all the way up to hour 11. So that's 12 hours in total. So if we want to go up to 11, then we have to put 12 in here because it's going to be whatever number here -1. And now if we print this data that we get back and we replace the existing text inside our JSON viewer, then when we take a look at it, you can see we've got the next 12 hours of weather data from 0 to 11. Once we've got that slice, the next step is, well, how do we get the rest of the stuff, right? What if I created a new list that contains the condition codes? We know that we've got a list of all of the weather conditions for the next 12 hours. How can we loop through that list to find out the actual ID of the weather condition for each of those hours? Well, we can create a for loop that looks at each of the data from the hour. So for hour data, in weather slice. So this is going to go through each of the 12 hours, and then for each of those hours, we're going to tap into the hour data and try to get hold of the item that is in the weather key, like this. Now I'm going to print each of these, and you can see we've now got a list of all of the weather conditions for each of those hours. Now let's narrow down that a little bit further. Let's get hold of the first item of each of these lists, and you can see in fact there's only one item in all of these lists. It's very rare that you have multiple weather conditions for each hour. Now that gives us a Python dictionary for each of those hours, and we can tap into that final value we're interested in under the key ID. So now we've looped through the next 12 hours and got hold of the weather condition ID for each of those hours. Now all we need to do is to save this instead of printing it, and we'll call it the condition code. And remember, previously we said that if the condition code is less than 700, then we're going to print bring an umbrella. So we can check if condition code, which remember at this point is still a string, so we have to turn that into an integer in order to be able to compare it against another number. If that condition code as an integer is less than 700, then we're going to print bring an umbrella. And you can see that for the next 12 hours, there's 6 hours which are going to rain at this particular place in Łódź in Poland that I've put into the latitude and longitude. Now, if I don't want to call this print statement many times, then we can define a variable outside the for loop called will rain, and we can set that to false to begin with. Now, if during the next 12 hours the condition code is less than 700, then we'll switch that to equal true instead. Now, after the for loop has completed, then we can check to see if it will rain in the next 12 hours, and if so, we'll print bring an umbrella. This way, we'll only get one print statement being called instead of every single time we land on a condition code for rain. So this involved quite a bit of JSON parsing and also understanding how to work with parameters and APIs. Now, I hope you managed to get this far by yourself, but if not, be sure to review what I've written and fix your code as required. If any of it was confusing, be sure to review previous lessons before you continue, because we're now building heavily on your previous knowledge that you learned through the course. Now, in the next lesson, we're going to be looking at how we can, instead of printing bring an umbrella, to send a SMS text message that notifies you to bring an umbrella instead. So for all of that and more, I'll see you on the next lesson. Now that we've got the hard part out of the way, figuring out when it's actually going to rain, the next step is to figure out how we can send this as an alert to our phone number using an SMS service. So for that, we're going to need to use a different API, the Twilio API. Twilio is an API service that allows us to send text messages or phone calls or have a virtual phone number in any country. And if you take a look at their front page, you can see there's actually a whole bunch of things you can do with the Twilio API. You could build an ordering system, you could create a video app, you could have SMS to email, whole bunch of things basically. Now, in order to create this service, they obviously had to build a lot of infrastructure, and they've invested a lot into making this seamless and work well. So that's why if you look at the pricing section, they do charge for their service if you're using it a lot. Now, in our case, we're going to get started using some trial credit. So they're going to give us $10 of trial credit, and we can test out all of the API and use any of their features. First, go ahead and click on Get Started for free. And you'll need to sign up to get a free Twilio account. No credit card required. Now, if you don't want to learn how to send a text message to yourself, that's also perfectly fine. You don't have to sign up. You can just do what we did previously using email. Once you've signed up with Twilio, you'll have to confirm your email and also confirm your actual phone number. Once you've completed confirming your email and your phone number, then it's going to take you to the console and it's going to ask you a few questions. Do you write code? Yes, of course we do. What's your preferred language? Python. And what's your goal today? Well, we're going to use Twilio in a project. And the first thing we want to do is to send or receive SMS. So now it's going to take us to our Twilio project dashboard. And it starts off by giving us some trial money. So this is the money that we can use to test out and use the Twilio API. Let's first start by clicking on Get a Trial Number. And it's going to generate for you an automatic number from the US. Now, if you want to, you can buy a number from a different country and you can start typing any of these numbers. But in our case, it doesn't actually matter where the number is from. We can simply just get the default number and click on Choose this number. So now we have a new phone number based in the US. We're ready to click Done and start using that Twilio number to send ourselves some SMS messages. Now we're going to head over to Docs and we're going to go over to Quick Starts. Now what we want to do is to follow this guide, the Programmable SMS Quick Start, in order to start sending SMS messages. So we're going to click on the Python section of that quick start, and you can see on the right, it gives us the example code that we need to implement in order to make this work. The first thing we need to do is to download the Twilio library in order to use it to import this client class. Let's go ahead and copy this into our project. So right below where we've got import requests, let's go ahead and paste this line of code that we copied, and you'll notice that it has some red underlines. This is because we need to install this Twilio module. So clicking on that underlined Twilio, we can click on the red light bulb and install this package. Once that's done, all of the errors should go away, and we can now start using this client class. Going back to the example code, we need to copy down our account SID and our auth token. We can get these details from the Twilio dashboard. Notice here that this account SID is basically the identification for my Twilio account, and the auth token we'll need to get from the dashboard. If we go to the console here on the top right, and we copy this auth token here, or you can click on Show to see it, then we can paste it in here and replace this auth token. And just for consistency's sake, I'm going to change this single quote to double quote. So these are both strings. Now, as I mentioned before, these IDs that you see on screen are not going to work for you. So make sure that you've actually logged on and confirmed all your details so that you can get your own account SID and auth token. Now let's head back to our quick start, and we've done all of this. What we need to do now is to set up a Twilio client using our account SID and auth token. Let's go ahead and create our client at the point where we want to send ourselves a SMS message. So I'm going to delete all of this, and instead of the print statement, we're going to set up our Twilio client. Next, we're going to create our message. So this is the message that we're going to send ourselves. The part that we need to change is the body. So this is the text that we're going to send ourselves. And then we're going to change the from field to the telephone number that we got from Twilio, and the to number to the telephone number that we signed up with Twilio with. So let's do one thing at a time. The message that I want to send myself is, as always, on a Mac, you can go to Edit, Emojis and Symbols to pull up the emoji keyboard. If you're on Windows or Linux, you can simply just head over to Google and search for an umbrella emoji and paste it in here. That's our message done. The next step is to figure out what is the telephone number that is going to be the sender's telephone number. Going back to our Twilio dashboard, we're going to copy this trial number here, and we're going to paste it in the from field as a string. The next thing is the to. So this is who the message is going to be sent to. This has to be the phone number that you used to sign up to Twilio. On the Twilio trial account, you can send messages and make calls to verified numbers. And you can add verified numbers by clicking on this plus button. And you can enter somebody's phone number, so your friends or family, but you have to be able to receive a message or receive a call in order to verify that you actually own that number or you have access to that number. Any of the numbers that you see here under verified caller IDs can be used in your code. Go ahead and replace this part where it says to with your verified number. Now, finally, it asks us to print the message that we created here, .sid. And basically what it means is that once this message has an ID created, it means it was sent successfully. Instead of printing the message SID, we're going to print the message status instead, just to make sure that it was actually sent successfully. All of this code is indented inside the will rain block, and this is what's going to be triggered if indeed it will rain today. Now let's go ahead and test this. But before we can test it, we have to find somewhere that's actually raining. It seems like people in Bern are getting quite a bit of rainfall, so let's update our latitude and longitude to Bern in Switzerland. Now that we've got somewhere that's raining, let's go ahead and run our code, and let's take a look at what happens on the phone. There you have it. We've got our message sent from our Twilio trial account. It's going to rain today. Remember to bring an umbrella. Now, of course, you'll be able to get rid of this part where it says sent from your Twilio trial account if you sign up for an actual account. But for all intents and purposes, this is working perfectly. And we're now able to receive an SMS when the weather condition in the next 12 hours contains some rain. So the very last thing we have to do is set up our Python script to run every morning at 7 a.m. Now that we've tested our code and we've managed to get it working locally, the next step is to put our script online so that it can be run on schedule and we don't have to manually open up PyCharm and run it every morning at 7 a.m. How do we do this? Well, we're going to use Python Anywhere, the same service that we used before when we created the automatic birthday wisher. Now, the first thing we're going to do is, of course, log into the service and we're going to delete all of our previous files. So that includes the letter template folder and also the main.py and the birthdays CSV. Now, instead of the previous main.py, we're going to upload our latest main.py. So let's go ahead and locate this in our computer. And then we're going to upload it to Python Anywhere. There you go. Now let's open up this file and click bash console here. So that's going to create our console down at the bottom. And once it's ready like this, we can enter the command to run this code. So it's Python 3, and then it's the name of our file, which is main.py. And because it's directly within my users folder, I don't have to specify a file path to it. Now, I don't recommend to have your main.py nested within other folders because it's going to make this a little bit more complicated. So as long as you've uploaded it to the same place that I have, just straight after your username, then we should be able to run this line of code. And we can test out whether if this code now works when it's being run from Python Anywhere. Now, what you'll see instead of the message status, however, is an exception. And it's a connection error. And the connection error tells us something about this API Twilio max retries exceeded with URL. So if we go ahead and highlight that, which will copy it, then we can paste it into Google and figure out what's wrong. The first post you can see is a post from help at Python Anywhere, and they've created this post to tell you how to get Twilio to work on free accounts with Python Anywhere. As they say, if you're trying to use Twilio on a Python Anywhere free account, you're going to run into an error that looks something like this, which is exactly what we got. And that's where Google Search picked it up to show us this article. The reason for this is because the Twilio API basically needs to be told how to connect to the proxy servers that free accounts use. When you have a paid account on Python Anywhere, you have an actual address to your dedicated server. But when you only sign up with a free account like we have here, we only get a proxy server, so we need to change the code a little bit in order for it to work. Even though we are actually using the latest version of Twilio, from testing I found that this code doesn't seem to work for me. Instead, we have to use this version of the fix that they've specified here. So the only difference from their version of the code and what we have here in our main.py is 3 lines of code. First, we have to import this class called Twilio HTTP client from the Twilio module. So let's copy that and paste it below our previous lines. Now, in addition, we have to create a proxy client with the Twilio HTTP client class that we just imported just now. So we're going to put that in our if statement when we're about to create our SMS message. The last step is where we have our client class being created. We have to set this HTTP client parameter to the proxy client that we created just now. That's going to go right here. The rest of the code we can leave as is, and we can simply hit save to update that code. Now, once we've typed all of that code, you can see we get an error in here. It says undefined name OS, and that's because this OS actually comes from an OS module. So we should import that in order for this error to go away. So let's hit save again, and you can see we're now free of warnings and errors. We're now ready to go into our console and to run the same command again, which is python3, and then it's the name of our file, main.py. So now when we hit enter, you can see we get back the message queued, which comes from this print statement. And that's because the status of our message has now been queued. And you can see I've now received the message from Twilio. And this is of course because my main.py was run on the Python Anywhere servers instead of from my local computer. So now that we've confirmed that this works, we can now finally go back to Python Anywhere and go to the task section in order to set up our task. Now here, I've still got my previous task set up when we created the automatic birthday wisher. Now, because I'm demoing this with a free Python Anywhere account, I can only create one scheduled task. If I start paying them, then I can schedule as many as I want, and they never expire. But because we're just learning here, I don't want you to commit to a paid account just to be able to see how it works. So we're going to use the same scheduled task. Now, if you don't have any tasks scheduled, just go ahead and create one, and the command is going to be the same. It's python3, and then it's running our main.py. So the same command that you entered previously. And we're going to set the frequency to daily, and it's going to run at 7 a.m. every day. In order to test this, I'm going to change the time from 7 a.m. to the current time. So the current server time is registering as 10:01, but in fact, I'm actually seeing 02. So I'm going to change that to 10:03 and then hit the check mark. And now I'm going to wait patiently to see if that is going to be triggered automatically from the scheduled tasks, and I get the SMS sent to my phone. And there you have it. This is now being sent to me from Twilio because we made the API call, but it's being sent because I've got this scheduled task, which is calling this command in order to run our main.py, and it's being done at a time which I've specified, which in fact I want to happen at probably 7 a.m. in the morning. Now notice that this is UTC time. So if you want to convert the UTC time to your local time, so at the moment we're on British summertime where I'm at, then you can type this into Google and change this to whatever time zone you're in. And that way you can figure out what time UTC is relative to your local time. In my case, it's just 1 hour behind. So if I want this to run at 7 a.m. my local time, then I have to change this to 6 o'clock. And now that's going to run every day at 6 a.m. without me needing to do anything. And I'm going to get my notification on time if it's going to rain. Now that we've got our app working, you might think we've reached the end of today's lessons, but there's just one final thing I want to talk to you about. And that is the environment. Not the environment as a whole, but more precisely, environment variables. Now, what are environment variables anyways? If you go into your PyCharm project and you go into this tab where it says terminal, here, if you type in env and hit enter, you can see a whole bunch of variables. So you've got a key and a value, and in between there is just a single equal sign. So these are the different variables that are set in the environment in which your code is run. These variables have values which are strings, which can be used in our applications or our code. Now, inside Python Anywhere, you can also type env, and you can see some slightly different environment variables, which are relative to the Python Anywhere environment. What exactly are these environment variables used for? Well, there's two major use cases. One is for convenience. Normally, when you deploy a large application, the process is quite complicated. And once you've done it, you kind of don't want to mess around with the code base and update the code files like your main.py, for example. Instead, you could have these environment variables which you can change. For example, if you had an application that was sending emails out to your clients, then your client-based emails might change day to day. So certain variables that are being used in your code base could be set as environment variables, and you could modify those variables without having to touch the code. A second reason might be for security. So when you're developing software, you might be uploading your code base somewhere, for example, to store it online or to a service like Python Anywhere. And it's usually not a good idea to have things like your authentication keys or your API keys to be stored in the same place as the rest of your code. That's where environment variables come in. So environment variables essentially allows us to separate out where we store our keys, our secret stuff, and various other variables away from where our code base is located. In our case, it doesn't really matter because we haven't got a paid account anywhere in here. It doesn't really matter if somebody steals our auth token or our API key because none of those are linked to our payment details. Now, however, if we were to upgrade our accounts on OpenWeatherMaps API or on Twilio's API, then we definitely want to keep these two things secret, the auth token and the API key. Instead of having it located in the same place where we've got our code base, which means you might accidentally upload it somewhere on the internet where other people can see it, instead we can store these two things as environment variables. We can create an environment variable by simply typing export and then the name of the variable, which I'll call OpenWeatherMap _ API key. And then it's really important that we have no spaces, but just a single equal sign. And then we're going to store everything that's in between the quotation marks. So I'm going to copy that from over here, and I'm going to paste that in here. Once I've exported that, and then if I hit env again, you'll see now in this updated environment, you can see that environment variable go in right there. And now we can tap into that environment variable in any of the code that we run from this particular environment. To do that, we have to use this OS module that we've already got. So I'm going to delete everything that's currently stored in the API key. And instead, I'm going to tap into os.environ. And then I'm going to use a method called get to get the value of a particular environment variable. The name is everything that's before the equal sign. So let's go ahead and paste it in here. And now when I run this code, so using Python 3 and then the name of the file, you can see that it successfully runs queuing our message into Twilio. Now go ahead and do the same thing with the auth token. You want to save this as an environment variable called auth_token in all caps, similar to what we've got here. And you want to store this value in the environment variable. Pause the video and give that a go. All right, so we're going to follow the exact same thing that we did before. We use the export keyword, and then we type in the name of the environment variable, which is going to be auth_token. And then, really importantly, we just have an equal sign, no spaces, and we're going to store this value without the double quotes, and we're going to put it in here. Now, in our environment variables, you can see we've got our OpenWeatherMap API key, and if we scroll up a bit more, you can see our auth token as well. So now we can replace this string with our os.environ.get, and then we pass in the name of the key, which is auth token. And now let's run our code again with Python 3 main.py, and you can see it still works as before. But now if somebody comes across this particular code base on the internet, they won't be able to use our Twilio account or our OpenWeatherMap account because both of these keys are now hidden. So let's go ahead and hit save. So now we're going to do the same thing, but at the point where we run our code from our task scheduler. So go ahead and right click on the snake and then open the link in a new tab so that we can go to our tasks section. And here we're going to edit our command. Instead of just running Python main.py, we're going to export those two environment variables. This is why we've got two screens open up so we can actually copy the actual values. The first value is going to be our OpenWeatherMap API key. So I'm going to copy that. And then here I'm going to write export and then paste in that first key. Now afterwards, I'm going to use a semicolon to denote a new line, and then I'm going to export the next key. Scrolling up, we can see our auth token right here. So we're going to copy that as well, and we're going to export that as the other environment variable. And then finally, we're going to cap it off with a semicolon. So now you should have your export OWM API key, and then you're exporting your auth token as well. And then finally, on the last line, we're running our Python 3 main.py. Now let's change this to run at the current time. So it's going to be UTC time, which happens to be 10 o'clock. And then instead of 46, it's now 48. So I'm going to change that to 49. And then I'm going to hit the tick. And now we're going to wait to see if it actually works, even though we've taken out the API keys from our main.py. Because we're exporting it in our command, let's see if we still get the notification message. There you have it. It's still working as before. But now this is invisible to people if they happen to access our main.py. Now, don't worry, the servers for Python Anywhere are pretty secure. Nobody's really going to hack into your account just to look into your main.py. The bigger problem is when you upload your own code to places like GitHub or Bitbucket, basically places that are essentially a Dropbox for code. And when you have it on there, because your code could be public, that's where the problem happens. If people look at your code file and they see that you've got API keys in there, then they might steal them. So whenever you're uploading your code publicly, always be careful that you strip it of all of the API keys and instead use environment variables like we have here to pull it from the environment. All that's left to do for you is to update your latitude and longitude to your actual local latitude and longitude instead of the rainy place that we're testing. And you've now completed the rain alert application. Now, I've showed you quite a few different APIs, but there's a whole world of APIs for you to explore. And if you have the patience to read their documentation and understand how to work with their APIs, then you now know how to work with their endpoints, how to pass parameters, and also how to authenticate yourself with their servers. So here's a list of fun APIs that you can use to build applications with. I've shown you how you can make a rain alert and send yourself SMS messages, or how to get the location of the ISS or the sunrise and sunset times, but there's a whole bunch of other APIs for you to explore. For example, things like the Open Movie Database API, which contains a whole bunch of movie-related data, or looking up songs and artists using the Spotify API, and a whole lot more. So I'll leave you to explore that. And if you come up with something innovative and interesting, be sure to share it with the rest of us in the Q&A below this lesson so that we can all check it out and admire your hard work.